have you ever looked up at the night sky and wondered how vast the universe is? Yes, thinking in such a way might cause mental confusion. Our understanding of the cosmos throughout our studies was restricted to the solar system. Furthermore, remember that the number of stars we have learned about is limited. Nevertheless, we will discuss the extent to which we may perceive the cosmos now. Let's start by discussing the actual amount of observation possible with telescopes. Imagine that we are standing exactly in the center of the enormous bubble representing the area of space visible to us from Earth, and the telescopes cover that. The cosmos is expanding perpetually, so the bubble is always becoming bigger. However, it has been discovered that the universe's age and the speed of light govern its development. On the other hand, the observable universe is considered 13.8 billion years old and has a diameter of 93 billion light years. Because it takes that long for light to come to us, this indicates that the furthest light we can see began to exist 13.8 billion years ago. This also applies to the universe's expansion, which is always happening and causes far-off things to travel faster away from us. This implies that our field of vision is limited. This is merely the portion of the cosmos that is visible to us. There's a chance that the cosmos is immensely more enormous. There are abundant galaxies, stars, gas, dust, dark matter, and dark energy across the visible universe. Even though we can only see a small portion of the observable universe, observers agree it is a large and fascinating place. But shortly, will the globe possess the technological capacity to track the entire bubble as it expands in this manner? Or will life exist on Earth beyond 13.8 billion light years? However, as was already noted, cosmic scales can be presented as a step toward observing beyond what is currently observable to humans. In modern cosmology, this technique calculates the correct distance to galaxies beyond our current field of view. Cosmic scales are a valuable tool for determining the relative solid distances between white dwarf supernovae galaxies. Nevertheless, the discovery of dark energy was made possible by this technique back in the late 1990s. Light years are a valuable unit of measurement for space distances, as proved by observations made with this approach. Here, a common approach is to calculate the annual speed of light, which comes out to be 9.5 trillion kilometers if we consider the temporal unit known as a light year. To be more precise, a light year is 9,460,730, 472,580, 800 meters, according to the IAU, and a year is 365.25 days. Similarly, the mean separation between any two stars in our galaxy, where we now reside, is approximately 5 light years, a value that is extremely near to the 4 light year gap between our Sun and Alpha Centauri. The Moon is a naturally occurring satellite, the Sun is a star, and the Earth is a planet. It is said that the Moon continuously changes its shape, whereas the Sun and the Earth do not. A year is the time for the Earth to complete one revolution around the Sun, 365 days. Comparably, Earth's average distance from the Moon is 384,400 kilometers. But Earth's average distance from the Sun is approximately 150 million kilometers, or 93 million miles. The next issue for them is how large the cosmos is compared to us. But it is no secret that people still have an insatiable desire to explore it. How can the size of this universe be comprehended? When you consider the computations, at least it's a rather bizarre notion. In other words, there are a total of 27 orders of magnitude in the circumference of the observable universe. It is approximately an octillion, to put it another way, more significant than the human body. But the average person finds it quite challenging to understand. However, scientists estimate that there are roughly 10,000 stars in every grain of sand on Earth for simplicity's sake. As we know, the amount of sand required to fill the cosmos has been calculated by the physicist Archimedes to be 1 multiplication 1063 grains. Philosophically, nonetheless, this idea is still astounding. According to modern technology, the notion of mathematicians has made it simpler to compute these. Our knowledge of the precise dimensions and form of the universe still needs to be completed, regardless of the methods used in these computations, observations, and excursions. It might be curved, flat, or even wackier. We still need to fully comprehend dark matter and dark energy, which are other enigmatic entities that appear to be impacting the universe's expansion. But is there a way for this cosmos to end? There is some scientific truth to the idea that the universe will collapse independently, but conceptualists who reject scientific viewpoints hold that this is not the case. The universe will eventually cease expanding and start to compress. If the mean density rises above the critical density, there will ultimately be a fireball like the one that caused the cosmos to expand. The Big Crunch is what we call this. People have been in awe of stars throughout recorded history. It serves as a reminder of how much more there is to discover about the universe. But that's the beauty of space exploration. It must be continuously investigated to unveil its mysteries. What is the universe's size then? It's enormous, constantly growing, and full of wonders that we're only now starting to discover. We are continually reminded of the observable universe, cosmic scales, and our size. Do you believe there are still mysteries in the universe? Of course there can be, given that no one has been able to properly learn anything about what exists beyond the visible universe. What then might the universe's mysteries be? Shortly, will an adventurer be searching for such mysteries? Make sure to subscribe to our channel if you want to learn about even more incredible science concepts. Have a nice day.